All right, this is E-DOT for covalent bonds. One of the first things that we notice is that we already have the formula for our covalent. This won't happen every time, but it will happen quite a bit. So we want to find our central atom. The central atom is normally alone, or it's the one that makes more bonds. So here, we're going to use our phosphorus. Look on our periodic table. It's in column 5A, so it has 5 valence electrons. 1, 2, 3, 4, 5. By going around, I prevent myself from making more pairs than I ought to. So first thing we're going to try are single bonds to see if all of our singles get paired up. So I'm going to try my phosphorus here. And I put it in the upper part of the box because I know I have 3 chlorines, which means they'll go on 3 sides. And with E-dots, we do everything kind of like in squares. So my first chlorine will go over here. 1, 2, 3, 4, 5, 6, 7. My other chlorine will go here. 1, 2, 3, 4, 5, 6, 7. And then my third chlorine will go on this side. 1, 2, 3, 4, 5, 6, 7. Now this time I circle my pairs. And the circle shows sharing. Covalents share their electrons. They do not transfer. All right, now finished E-dot. My E-dot's pretty well finished here. And so structural formula, all we do is we change our E-dot bonds to lines. And we only preserve the dots for the central atom. We don't have to do them around all the others. So you can see that I tell you chemists are a little bit lazy, so yeah, they don't draw the dots except for the central one. If I had any funny mistakes or anything, then I would rewrite this in the finished E-dot. Or if single bonds didn't work, then again, I would do a finished E-dot. All right, so here we go. We're going to have that exact situation come up right here. So I'm going to have O2. There's not a central atom because it's just 2. I look on the periodic table. Oxygen has 6 valence electrons. I'm going to try a single bond and see if that will pair up our 2 oxygens. And I'm going to manipulate it so my singles are in between my 2 oxygens. All right, so a single bond would be 1 bond between the 2, so 1 pair that is shared. Now, both oxygens have another set that can be shared together. So just like in ionic where you would draw a second arrow, in this case, we're going to make a second circle. So my first oxygen, my second oxygen. So here's our first shared bond, and then here's our second shared bond. So I'm just going to move my dot and my X in between the 2 letters. So my structural formula really makes sense. I've got 2 shared pairs, and so I've got the 2 bonds. And then again, I keep the pairs. Normally on the central atom, but we don't have 3, so it's just going to be on both of them. All right, structural formula just changes your bonds into lines. All right, carbon dioxide, we're going to go through the same process. We do have a central atom, so that's the one that's either a single or it comes first. Carbon has 4 valence electrons, so we're just going to do the 4 dots. I'm going to try single bonds, so my central atom kind of goes in the center. So oxygen, There's a single bond, and then the other oxygen is going to go over here. And it's single bond. So notice that the atoms are not satisfied. I've got singles both on carbon and on oxygen, so single bonds don't work. So we're going to try that double bond like we did before. And we're going to rewrite our atom. And this time I'm going to move my dots into the center. So the one that was below is going to come up. And so I'm going to have two shared bonds. And for this oxygen, we could say it's above one, move down. But it doesn't really matter where it moved from. They do have to move in between the two letters. And so my structural formula then would be oxygen, 2 bonds, carbon, 2 bonds, the other oxygen. All right, and the last one quickly, we have nitrogen. Again, no central atom because there's only 2, so I just choose one of the nitrogens. 1, 2, 3, 4, 5. I try a single bond. 1, 2, 3, 4, 5. And my other nitrogen, single bond, doesn't work, but both of them have more singles to offer. So I'm going to clean it up by having three shared bonds in the middle. And my structural formula is going to have 1, 2, 3 lines like that. That's a triple bond.